Okay, let us discuss a question. We have a question from a solid state, class 12th, and this is our question. The question is the edge length of a FCC unit cell. The edge length of a FCC unit cell is 508 picometer. Fine. If the radius of cation, if the radius of cation is 110 picometer, then calculate the radius of anion. See, this is a question. We have options like option A is 144 picometer, option B is 288 picometer, option C is 398 picometer, and option D is 618 picometer. So in order to answer this question, see, if we have a FCC unit cell, something like this, then the cation is actually present at the octahedral void. So let's say this is cation surrounded by two anions, and this length is edge length A. So if we write A, then it becomes 2RC plus RA. How this is 2RC, this is RA, and this is RA. So this will become 2RC plus RA. So we have been given A. Fine. So RC plus RA will be A by 2. So if we calculate RC plus RA, then it is 254. Now RC we have been given, it is 110. So RA in this case will become, RA is 254 minus 110, that will be 144 picometer. So the correct response for this question is option A. So let us move on to the next question. The next question is, in an FCC unit cell, what have we been given? In an FCC unit cell, atom A occupies corner positions, and atom B occupies face centers. Atom B occupies face centers. So question is, if one of the atom B is missing from one of its lattice sites, then determine the formula of the resulting ionic compound. See, basically in an FCC unit cell, if we talk about FCC unit cell, then we have 8 corners. So A will become 8 times 1 by 8, so it is 1. And B, we have actually 6 face centers. In an FCC unit cell, I hope everybody knows there are 6 face centers and 8 corners. So B will become 6 into 1 by 2, so it will become 3. So if one of the B is missing, then A will remain 1 and B will become 3 minus 1 by 2, so it will become 5 by 2. So A, we have A1 and B 5 by 2, so it will become A2 B5. So that's our formula, it's A2 B5. Now moving on to the next question. Our next question is, lithium forms BCC structure. Lithium forms BCC structure, and if the length of its unit cell is equal to 351 picometer, you can consider this to be edge length. So if this is edge length, and we are supposed to calculate, let's say find out the radius of lithium atom, radius of Li atom. So it's very easy. We know that in case of BCC, the structure is root 3a is equal to 4r. So r is root 3 by 4a. So we have to calculate root 3 into 351 upon 4. So that is our answer in picometer. Fine. Let us take up another question. For the following reaction, establish a relationship between rate of disappearance of products, rate of disappearance of reactants, and rate of appearance of products, So suppose we have a relation 2N2 forms 3H2 and gives 2NH3. Let's make it correction. It is N2 plus 3H2 forms 2NH3. So for a reaction like this, AA plus BB gives CC and DD. We know that the actual relation is minus 1 by A, dA by dt is equal to minus 1 by B, dB by dt. Where these are the rate of disappearances. This is equal to 1 by C, dC by dt, and 1 by D, dd by dt. This is rate of appearance. So in this case, we have a question like we have relation N2 plus 3H2 forms 2NH3. So we can simply write like this is the rate of disappearance will be defined for these compounds and rate of appearance will be defined for this compound. So we can simply write minus dN2 upon dt is equal to minus 1 by 3 dH2 upon dt. This will be 1 by 2 d NH3 upon dt. So this is our relation. Fine. So this was our relation.